Alright, so we have CIS-125, and this is 9/26/16, day 8, I believe. Alright, here's what we talked about today. Told the students they need to review the syllabus. At the end there's a general timeline for the course, and then there's an academic calendar, so you're aware of when things are due. Self-review. The students are to do a self-review. I'll make sure that's available. I told them checklist. They can check the whiteboard reviews. We talked about today we're on module. We're going to talk about coding, and then we'll talk about work in a group. A couple things I've noticed. We talk about flow arrows. Make sure, typically we go down and to the right, as shown right here, but things, some people in their design, they need to work their way. They don't have enough room, so they're doing this, but instead you could use this option. You can use an indicator 1 here, an indicator here, and then move from here to here, and then continue your flow. Now down and to the right, that doesn't always work. When you have a loop, you got to go back up. Okay, so when you have a loop, go up. If you can't fit it on a page, you can use a page connector. You can indicate something here, and you would indicate the same thing on the next page. Okay, and if it was multiple pages away, you could put a reference to this and explain where to go. Last thing here, on the preliminary information, we talked about how to name the files. Assignment 1 dash your initials dash and then the name of the assignment, so that we can keep track of them. That's how we want to name them. Alright, so that's your initials, not mine. Next thing, we talked a little bit about modules today. For example, we can import a math module. Okay, it's kind of like that part we talked about. You create the source code, and the compiler then creates an object code. Now in more machine language, and then that can be linked and combined. Actually combine it with some other code to give us executable code. So we can import in Python all kinds of code for doing math from the Python library. The Python library is very extensive. Lots of code you can bring in, which is really handy. Program code. It's a number of lines of code. So just as a reminder, that sits on storage. Okay, could be solid state, that'd be nice. We bring the code in and we function the code. We get this communication back and forth between the processor. Okay, as it executes, storing things in memory, the processor doing the work. And we gave the example years ago. We used to code what we called pages. Term still used. You'd create just a page of code. You'd make sure it was not over a certain length, so that that page would fit in memory. So initially, a lot of programming, the idea of doing it in modules, you could write these modules so that they would fit in memory, plus you could reuse some of them. Okay? Smart, huh? Just like the math functions. All we got to do is bring them in and use them into our program when it gets linked. Okay? Now, current day programs, let's just say you have Adobe Suite, and you load a piece of software there, which is huge. It'll bring in the memory what it needs. Okay, it'll bring in the memory what it needs, and then it'll leave the rest out here in virtual memory. It looks like memory, but it's on the hard drive. So what's important there is this communication becomes crucial. The speed of bringing it in. Huge advantage of solid state. Alright, so we cover modules in the second half of the class more specifically, but we'll need to use them here pretty soon. Alright, we walk through the process. We have all the information, the analysis, the design, and we understand the problem. We create the IPO. And then in this case here, we flow chart it. Okay, we have to have, we're going to flow chart, we talk about that. We have a legend, you have the design, flow chart, pseudocode, got a walkthrough, peer review, all this work before we start to code. Before we start to code. And then the code needs to give us the location of where the code's at and who peer reviewed it, who checked it. This should be somewhat of a review, but we should know that. Somebody asked initialization box what we would use that for. The issue here, some people were actually putting too many things up here. Really, you just need to set, like if you have some constants, an example we used was pi, you could set that equal to however many decimal places you were going to use. If you had some other constant, like 1.5 might be your overtime rate, you could set, overtime rate to that. If you use something like that, you better put it in the legend, a variable like that, in order to understand it. We'll keep working on that. I can tell there's some questions on that. Alright. We use VI. It's a text editor. You need to be in insert mode to get it to work. We use escape to get out. Colon WQ. The W will write. The Q means quit. We made a directory, a bin directory. We changed to that directory. We did a long listing to see what was in the directory, and this just does a listing of the directory. You can easily find information on Linux and some of the items we talk about. Like, for example, we talked about how to clear the screen and then change the mode. We need to change the mode for the file. We give the rights and which file or directory we're changing. Okay. We also talked about syntax. Cat, that will print out what's on this file on the screen. So will less. There's the name of the file, but you have to use a Q to get out of that. This will let you scroll up and down in the file, which is nice. And now here's some code. We did an example in class. I'll try to highlight a couple things here. Name of the file, so I just typed it right there at the prompt. Took it from storage into memory. Okay. And then once it's in memory, it used, here is in the program, it used that interpreter to check the lines of code to make sure the syntax was okay. Once it did, then it started executing. These things are just comments. So it skips over those, and then it does this. It initialized perimeter to 0.0, feet per gallon, initialize that to 300, and then length, it's going to input a float right there, and so that line is this right there. So this line was sent to the processor right here. This line was sent to the processor. The processor required some input because of the action word here. Has that command built into the line, so it went to the screen, it printed what was right here, and then it waited for us to put something in. We typed 400, press enter, it went to the next line. Similar situation, input, gave us a prompt. So this line is this one. We typed in 600, and then it went, got length out of memory and width out of memory. So here we inputted the length, and here we inputted the width. As you see up here, they were stored in memory somewheres. So it grabbed both of those, it added them together, and took them times 2. And it added them first because of the parenthesis. Then it took this value, perimeter, and divided it by this value. So this value is already in memory. Where did it go in memory? Right here. We put it in memory at that point. And so it takes this from memory and this from memory, divides them, whatever's stored in those, divides it, and stores that back into this. And we go print, gallons used, here. Prints whatever's stored in memory. That's it. It's the explanation of how that works. We will look at more of those as we move along. That's it for today.